Hello, this is Dr. Harris again with more examples involving the chain rule. So this is mostly stuff that was on the handout I gave in the last class period before the break, but I've added a couple of things and just want to talk through these examples and see what questions you might have when we get together to talk in the near future. So our first example today is going to be one where we look at applying the chain rule when we've got a composition of three functions. And so I might write it as y equals f of g of h of x. And so my shorthand, rather than call them f, g, and h, I'm going to refer to them as outside, middle, and inside. And so h is the innermost, that's the inside function, then g is our middle, and f is going to be our outside here. So let's take a look. If we want to apply the chain rule to this, we want to realize that f is being composed with something. And so we're going to apply the chain rule. And so the derivative is going to be the derivative of the outside function replaced with what's inside it. But since what's inside it is itself a composition, we're going to apply the chain rule to that. And so we'll get the derivative of the middle function, and we'll stick what's inside it, the inside function, and then multiply all that by the derivative of the inside. So at some level, this is the derivative of the outside times the derivative of the middle times the derivative of the inside, but there's appropriate composition going on. So I've tried to write that out here. It's the derivative of the outside function composed with what's inside it, which is the middle composed with the inside. The derivative of the middle composed with the inside, and we multiply that finally by the derivative of the inside function. So let's apply that to this example here, y equals cosine to the fifth of x to the seventh plus 2. So we want to recognize that this is a composition of three functions. Hopefully we can recognize that the innermost one is x to the seventh plus 2, so I'm calling that the inside. And then what we're applying to x to the seventh plus 2 is the cosine function. We're going to take cosine of x to the seventh plus 2. That puts the cosine in the middle, and finally we're raising cosine of x to the seventh plus 2 all to the fifth power. So again, we've got to have that vital skill of recognizing what's outside, what's inside, but then we've got this extra step here of figuring out what's in the middle. And just as a reminder, over here I've got the derivatives of those three functions. So now let's see what we do to calculate the derivative of this function. And so I'm going to try to at least start by thinking about it in this way here, where it's just the derivative of the outside times the derivative of the middle times the derivative of the inside. And I'm going to temporarily skip over the composing part. So the derivative of the outside function is 5 something to the fourth power. So we'll put that here. So it's 5 something to the fourth times minus sine of something times 7x to the sixth. So at this point, I've really got the derivative of the outside times the derivative of the middle times the derivative of the inside. And what I haven't done is I haven't done any of the composition here. And so first of all, I need to figure out what is inside this piece right here. And so it's going to be 5 of, well, it's going to be cosine of x to the seventh plus 2. And so that's the middle composed with the inside here. So I'm going to have cosine of x to the seventh plus 2. That's what goes inside there. And then here, it's going to be minus sine of what's inside the cosine function originally, the inside function. And so that's also going to be x to the seventh plus 2. And this is actually the solution to this problem. So again, let's review. It's going to be the derivative of the outside, 5 something to the fourth, but the something that's being raised to the fourth is what was being raised to the fifth earlier, cosine of x to the seventh plus 2, times the derivative of the middle minus sine of what was inside the cosine function originally. That's going to be x to the seventh plus 2 times the derivative of x to the seventh plus 2. Derivative of the outside times the derivative of the middle times the derivative of the inside. Now let's scroll down and look at 3 other examples. And here we're just given pieces of information about the values of a function or its derivative at a very few select points. And we're asking to compute the value of the derivative at a particular value of x. And so in the first example, what's the derivative of y equals f of x to the fourth at x equals 2? We want to see this as a composition. We're taking f of x, our inside function, and raising it to the fourth power. And so we have a composition here. The outside function is x to the fourth. The inside function is f of x. And what we're going to do first, before we try to plug in 2, is, remember, we don't stick the numbers in first because the derivative of the constant is 0. So we're going to take the derivative first and then plug in 2 and see what we get. And so we use the chain rule. It's the derivative of the outside function. So it's going to be 4 something to the third power times the derivative of the inside function. So it's 4 something to the third times the derivative of the inside. And what goes in here is the outside function. And so our derivative is 4 f of x to the third times f prime of x. And so to find out what the derivative at 2 is, we plug in 2. And so y prime of 2 is going to be 4 times f of 2 cubed times f prime of 2. And we can use the information up here to substitute in. And so it's going to be 4 times f of 2 is 4. So I get 4 times 4 cubed times f prime of 2, which is 3. And if we do that multiplication, 4 cubed is 64, 4 times 64 is 256, 3 times 256 is 768. So our answer in this case is 768, and that's something you can do with a calculator, obviously. Let's go down to the next example. What's the derivative of f of g of x at x equals 1? Pretty straightforward composition here. G is on the inside, f is on the outside, and so our chain rule says that the derivative is going to be the derivative of the outside, f prime, composed with the inside, times the derivative of the inside. So it's f prime of g of x times g prime of x, which means that y prime of 1 is going to be f prime of g of 1 times g prime of 1. And then we come up here to the top to look up this information. G of 1 is 2, and so it's going to be f prime of 2 times g prime of 1. F prime of 2, we were told, is is 3, and g prime of 1 is negative 4, and that's going to get us negative 12. So our answer to the second question is negative 12. Finally, we have another somewhat interesting example. Y equals f of x squared. We want to know the value of the derivative when x equals 2. This is a chain rule situation where x squared is on the inside, f of x is on the outside, and so y prime is going to be the derivative of the outside. evaluated or composed with the inside. Inside this case is x squared. We multiply that by the derivative of the inside, which is 2x. So y prime of 2 is going to be f prime of 2 squared. I'll plug in 2 for x, times 2 times 2. 2 squared is 4, so now we're looking at f prime of 4 times 4. And we're told above that f prime of 4 is negative 5. Negative 5 times 4 is negative 20. And that's our answer here. So please feel free to look over these examples again. And that should be an equal sign there. And let me know when we get together on video, or you can ask me via email any questions you have about any of this. Thanks, and look forward to talking with you in the near future.